Which transformations are needed to change the parent sine function to the sine function shown here? So of course the parent sine function y equals sine x. So the parent function has an amplitude equal to 1. That means normally it starts here and it goes up to a height of 1 and it falls to a low of -1, and that's an amplitude of 1. So looking at this graph, I can tell that this is the midline. Okay, so this graph from the middle, does it go up 1 and down 1? No, this goes up 1/2 of a unit. Right? This is only half, and it only goes down half. So this has an amplitude of 1/2. So that means that there's a vertical compression of 1/2. So let's write that down. Okay, now what about horizontally? Well, normally one cycle of the sine function is a length of 2 pi on the x-axis. In other words, the period is 2 pi. Now, let's see, what's the length of one cycle on this particular graph? Well, okay, even though the sine function, like this would be one cycle of this sine function, and I can tell that it goes from -pi to 3 pi, so that's a total of 4 pi. Okay, but it would have been fine to use this portion of the graph that's even easier to see. Even though this looks like a cosine, all right, we can think of this entire graph is a shifted sine function. Anyway, the point is it's easy to see the period from crest to crest, and it ends here at 4 pi. So look, the period is normally 2 pi, and now the period is 4 pi. That's double. So that is a horizontal stretch to a period of 4 pi. Okay, I think I'll just squeeze that in right here. Horizontal horizontal stretch to a period of 4 pi. Okay, what else? I sort of mentioned this earlier, but normally the midline is the x-axis, and here the midline is at 1. That means that there's a vertical shift of up 1. Okay, now also normally the sine function starts at 0. Okay, now if I look at this function, okay, the pattern, I could look at it as starting from here. So that would be a phase shift of -pi. It just depends on how you look at it, okay? It could be a phase shift of -pi, or if we look at another portion of it, like the one that starts over here, then maybe it's a phase shift of 3 pi. And in fact, because there's so many different answers for phase shift, I'm going to see how many of these answers I can rule out based on what we've already said. So let's see if we can get the answer just from the three things I said first. So let's see. Vertical compression of 1/2. Okay, that's good so far. Horizontal stretch to a period of 4 pi. Okay, we had that. Vertical shift up 1. We have that. Okay, now phase shift of pi units left. Well, that even matches what I said there at the end. So this first one is definitely going to be the answer. Now, we got lucky there, but notice that even without the phase shift, we still would know that this was the answer. This one says a vertical stretch of 2, but it was a compression, so we would have known this was not the answer. This one says a period of 2 pi. Well, clearly the period is 4 pi, so we would know that that was not the answer. This one again says compression. Oh no, that was the correct thing. That's not the problem. This one again says period of 2 pi, so that would be wrong. So even without the phase shift, which can be written multiple ways, we still would know that the first one was the answer.